straight line. Motion in straight line is a part of kinematics. Kinematics is a part of mechanics, which is a study of motion. So
Good
we say
evening, sir.
that a body is in motion if its position changes with time, and if its position does not change with time, it is at rest. And rest and motion are relative terms. Depends on the frame of reference or the point from which you are observing the motion of that particular body. Then the first thing that the first two terms that we must understand to understand motion are distance and displacement. Distance, actual path length traveled; displacement, shortest path between initial and final positions. This is scalar, that is vector, and this was one example how to calculate distance and displacement in a given situation.
Good
Let
evening,
us
sir.
take one. Good evening. Good evening. Let us take one more example to make this clear.
Sir,
Oh,
sir, I had doubt in yesterday's class, sir.
hmm.
Sir, you wrote that there's no object in universe which is at absolute rest. So it
Oh,
means that objects in the universe, like bodies in the universe, will be at rest only for some time, right?
no, they are continuously moving.
Okay, sir.
Right. So situation is a body is moving along a circular path of radius r. Okay. Let us say the body starts from here. This is the circular path, center, and this is the radius r. Center O. This is point A. This is point B. This is C, and this is D. If we take different paths and try to find out distance and displacement, let us say body starts from A and it goes to C. Starts from A and goes to C. It is moving along circular path like this in anti-clockwise direction. So body starts from A, goes to C and stops there. Then the distance covered by that body is
Fire.
uh, distance covered is actual path length. So you have to measure this total path along the circumference of the circle. This is half of the circumference, 2 pi r by 2, which is pi r.
Yes, sir. Next,
Distance covered is,
displacement to what, sir?
The displacement 2r.
uh, yes, yes, wait, wait. Then displacement between point A and point C is the shortest path as per the definition of displacement, shortest path between A and C. And shortest path between 2 points will always be a straight line. Keep this point in mind. Shortest path between 2 points will always be a straight line. It can never be a curve. So shortest path between A and C is a straight line connecting A and C, which is the diameter of this circle. Diameter of the circle is 2r. Okay. Next, the body starts from A, then goes to B, goes to C, goes to D, and stops at A. Returns to the same point.
2
Then
by the
the
distance, sir.
distance covered by the body
2 by
is
r.
circumference of the circle 2 pi r. Displacement of the body
0,
is
sir.
0 because initial and final positions are the same. Body starts from A and goes to B. Starts from A, goes to B. Covers quarter of the circle. That means its distance is quarter of the circle, 2 pi r by 4. which is pi r by 2. This total path length, A to B, quarter circle or quarter of circumference, 2 pi r by 4, pi r by 2. Okay, then its displacement is between A and B. Displacement of the body is how much? Displacement, actually calculating or finding displacement is very easy. I don't know why some students get confused with this. Here, when compared to distance, finding displacement is easier, because to calculate displacement, you have to look at only 2 points, starting and stopping, initial and final points. That's all. Whereas distance, it can belong any path. We should go along with the body wherever it is going. We should follow it to find out distance. But to find
Sir,
out distance,
root
it
2r.
is very simple. You look at the starting point. You look at the final point. That's all. You connect them with a straight line.
Sir, root 2r.
Oh.
Root 2r squares.
This is the displacement from A to B.
I have a doubt.
This is the displacement from A to B. How much is this displacement? This is radius of the circle. This is also radius of the circle. It is a right angle triangle OAB.
The
If you
2r
apply
square equals
Pythagoras
to
theorem,
AB
this will
square.
be root of r square plus r square, which is root 2r square, which is root 2 into r.
Sir, how did we get the displacement of the first answer? A to C.
What is the definition of displacement?
The shortest path, sir.
Between?
The shortest way from the initial point to the final point.
What is the initial point here?
A, sir.
Final point?
C.
What is the shortest distance between them?
2r, sir.
Oh. Is it the diameter?
Yes, sir.
Diameter is twice the radius.
Yes, sir. 2r.
So from A to B, displacement is root 2r. Displacement is root 2r. Okay, if let us say the body starts from A, it goes to B, B to C, then C to D. It stops at D. Distance is A to B pi r by 2,
I think 3 pi
B
r
to
by
C
4.
pi r by 2, C to D pi r by 2, 3 pi r by 2. 3 pi r by 2 is the distance from A to D. Displacement.
So same, sir, root 2r.
Displacement is again same thing. Starting point, initial point is A, final point is D. It is starting from A, stopping at D. While writing displacement, you need not bother, you need not worry where that particle is going, what is the path followed by that body. Displacement is independent of path followed. It depends only on initial and final positions. So while writing displacement, don't look at the path traveled by the body. Look at only initial and final positions and connect them with a straight line. This is radius. This is already radius. This from triangle OAD, which is the right angle triangle. This is the hypotenuse. Hypotenuse is root of side square plus side square. This is again root 2 into r. So this displacement is also root 2r. Like this, you can calculate distance and displacement in any given situation, which is very fundamental and basic thing in studying motion, distance and displacement. Okay, next, moving to the next topic, which is speed and velocity. If a body is in motion,
Distance per unit area, sir. See, distance per unit area.
yes, wait. So if a body is moving, it will be covering certain distance in certain time, or it will be having certain displacement in certain time. What is the rate at which distance is being covered by the body is expressed with speed or velocity. Speed is a very common term, common word that we use. Don't go speed, drive slowly. Speed thrills but kills. You might have seen signs on the highways. So fast driving is very dangerous. You should restrict your speed. Speed limits will be there on the highways. Okay, and you run speed, you walk speed, you do some things fast. This is what we mean by speed in day-to-day life. In physics, how we define speed is if a body is in motion, its speed is defined as it is the distance covered in unit time. Distance covered in unit time, speed. So mathematically, speed is equal to
D by D, sir.
distance by time. Distance by time. And the standard symbols that we use are speed is represented by V, not with S. Distance is represented by D and time with T. Standard representation, which is followed in most of the books. So it is better if you also follow this. Distance by time. Speed is distance by time.
Sir, what is V?
Speed. Speed is V. Speed is denoted
Sir,
by V.
velocity is also V on N, sir.
Yes.
It is V bar, sir.
So we have the definition and formula for speed. Then what is the unit in which speed is measured? SI unit of measuring speed is meter
Per second square.
per second. Meter per second. Meter per second. And other units are practical unit. Normally, if you
Kilometer per hour.
what do you call a device which measures the speed of automobiles?
Speedometer, sir.
Speedometer. Speedometer. You have speedometer in your automobiles, two-wheelers, four-wheelers. Everything has this. In that speedometer, speed is graduated. The scale is graduated in kilometer per hour, not in meter per second. So kilometer per hour is a practically used unit. Kilometer per hour. Practical unit is kilometer per hour. Practical unit of speed is kilometer per hour. And here we should know a basic point is wherever you are substituting values in the formula, you should take care that all the values are in SI, standard units, international units that are followed. In questions, sometimes speed might be given in kilometer per hour. To use it in the, or to substitute that thing in the formula, to use, substitute the values, you cannot substitute it in kilometer per hour. You should substitute, you should convert that kilometer per hour into meter per second,
Yes,
then
sir. 5 by
substitute.
8, sir.
So how can we convert kilometer per hour into meter per second? It's a simple conversion.
Yes, sir.
Suppose if I ask you to convert centimeter into meter, you will say 100 centimeter equal to 1 meter. Or if I want you to convert meter into kilometer, you will say 1000 meter is equal to 1 kilometer. Like that, how many kilometer per hour is meter per second, or how many meter per second is 1 kilometer per hour? To do this conversion,
8 and
it
5,
is
8 by
simple.
50.
Why that 5 by 18 or why that 18 by 5?
Because
So practically means it's given in most of the problems.
Yes.
Okay.
1 kilometer per hour is 1 into Kilo is a
1000 meters, sir.
multiple.
1000 meters by 60 to 60.
1 kilometer is 1000 meter
By 60 to
divided
60, sir.
hour. If I convert hour into seconds,
Seconds. 60 into 60
60 minute into 60 seconds.
seconds.
0, 0, 0, 0 gone. This is 3 twos, or sorry, 2 threes, 2 fives. So which I get 1
5 by 8.
kilometer per hour is
I got
equal to
5
5
by 80
by
meters per second.
18 meter per second. Or if I interchange this, I'll get 1 meter per second is
Equal
equal
to
to
80 by 5
by
hours.
5 kilometer per hour. So this is the conversion factor which you should remember. This is how you get it, and this is what you should remember. For example, say 72 kilometer per hour speed is equal to 72 into 5 by 18 meter per second, which is 18 ones, 18 fours,
20
20
meters per
meters
second, sir.
per second. So 72 kilometer per hour is 20 meter per second. Right, this is the unit. The definition of speed, formula for speed, unit for speed, conversion between SI unit and practical unit. Then what is its nature? Speed is a scalar quantity.
This is square quantity.
Speed is a scalar quantity. Okay. And speed will always be positive. Speed can never be negative or zero if a body is moving, because distance, speed is basically distance by time. Distance can never be negative, which we discussed yesterday, and time can also be never be negative. So two positive quantities divided will always give a positive quantity. Speed will always be positive. Speed will always be positive. Okay. Next thing, velocity.
Displacement per unit time, sir.
Yes, yes. Wait. Let us go slowly. As we define the speed as distance covered by a body in unit time, velocity is the displacement of the body in unit time. Displacement of the body unit time. As there is a lot of difference between distance and displacement. Similarly, there is a lot of difference between speed and velocity. They are not the same. They might appear to be same conceptually, but technically they are different. Speed also tells you how fast a body is moving. Velocity also tells you how fast a body is moving, but there is a fundamental difference between them. Speed measures the rate of change of distance. Velocity measures the rate of change of displacement.
Yes, sir.
So velocity is displacement by time.
Sir, velocity will always be in a straight line.
Need not be. It can change direction. And the standard symbols that we use to represent velocity are: velocity is represented by V,
V bar.
displacement by S and time by T.
Sir, it is V again,
Yes, V.
not V bar, sir.
You can write, no, don't read it as V bar. If you want to say it as vector V or V vector. It's not V bar. You get bars in mathematics.
Sir, S
There
is
are
displacement,
there
sir.
are no bars in physics. It's V vector or velocity vector.
Sir,
V
displacement
represents
S, sir.
velocity. S means S is used to represent displacement. T is time. In some books, even distance is also represented by S. Anything can be followed, but it is better to have different representations so that it will be clear that this is distance, this is displacement. But whatever it is, you should, from that given situation, you should understand what is given, whether is it distance or whether is it displacement. Are you asked to calculate speed or are you asked to calculate velocity? You should understand from the given situation by reading the question. So velocity is displacement by time. SI unit of velocity is also the same, meter per second. And even if velocity is given in kilometer per hour, procedure to convert it into meter per second is also same. Multiply by 5 by 80. You will get velocity in meter per second. But here, velocity is a vector
Vector
quantity.
quantity.
Velocity is a vector quantity. That means you should understand this difference here. Speed is scalar, velocity is vector. That means if from our discussion and from our knowledge of vectors, we can say that velocity is speed with direction. Velocity is speed with direction. If you don't specify direction, it's speed. If you allot a direction to speed, it becomes velocity. Like if I tell a car is moving at 5 meter per second. A car is moving at 5 meter per second. From this, what do you understand? You will see a car. You should see a car, and that car is moving with a speed of 5 meter per second. 5 meter per second. What does this mean? 5 meter per second means
Speed, sir.
the car is covering 5 meter in every 1 second. It starts at time t equal to 0 here. At time t is equal to 1 second, 2 second, 3 second, 4 second. This distance is 5 meter. Second also 5 meter. Third second also 5 meter. Fourth second also 5 meter. So every second it is covering a distance of 5 meter. Then we say that its speed is 5 meter per second. That is what this thing means. 5 meter per second. 5 meter every second. Okay. If I tell you that this sentence, a car is moving at 5 meter per second, you see a car which is going at 5 meter per second, but you cannot be sure in which direction the car is going. It might be going to east or west or north or south or northeast or southwest. It might be going in any possible direction. That direction is not specified here. So if direction is not specified, it is not a vector, it is a scalar quantity. That's why speed is just a scalar quantity. But if I tell you, that means this statement, a car moving at 5 meter per second is not conveying you the entire information of the motion of that car. It is only giving you magnitude. It is only giving you magnitude
It is not
of
telling the
speed.
direction, sir.
So it is not giving you the complete information. If you want to completely describe the motion of that car, if you want to completely understand the motion of that car, then you must specify the direction also. If I say, since just modify it like a car is moving at 5 meter per second towards east, then this gives you a exact picture. The motion of that car is completely described by this statement. 5 meter per second gives you the magnitude, east gives you the direction. And of course, we don't always use east, west, north, south. We have our own method to represent directions in vectors by using IJK unit vectors. We will be using IJK unit vectors to specify the direction. So, what is the difference between the first sentence and first statement and second statement? First statement gives you only magnitude. That's what we call as speed. Second statement gives you magnitude and direction also. So, this is velocity. 5 meter per second towards east is velocity. Only 5 meter per second is speed. Is the difference
Sir?
clear?
Sir, will the velocity, how can we represent velocity with IJK units, sir? Or does it change with the frame of reference?
Velocity changes with frame of reference.
So then how can we represent with IJK units, sir?
If I want to tell that the car is going towards east, I will take x axis along east direction and write the speed of the car. I write the velocity of the car as 5 meter per second. I will fix the reference frame.
Okay, sir.
Velocity. And velocity, as it is displacement by time, displacement can be positive, negative, 0. Velocity can also be positive, negative, 0. Velocity can be positive, negative, or even 0. How, in what situations will it be negative and what will it be 0? We'll come to that later while doing the examples. Now, what I want is you should just get a comparison and clarity, differences and similarities between speed and velocity. Speed is a completely different thing, velocity is a completely different thing. Velocity has direction. Direction will be there, direction will be specified. Speed has no direction. Now, again, let us take speed. We can calculate two types of speed for a body. We can calculate two types of speed for a body. What are they? One is called average speed, and the other is called instantaneous speed. Average speed and instantaneous speed. What do these two terms mean fundamentally? Let us take instantaneous speed first. Instantaneous, the term itself says instantaneous means value or speed of the body at a particular instant of time. It is the speed of a body at a particular instant of time. Particular instant of time. What does this mean? Suppose a body is traveling, say a car. It starts at time t equal to 0, 1 second, 2 second, 3 second, 4 second. It's traveling with some speed. That speed might be constant, that speed might be changing with time, anything. If I calculate or if I measure or if I take the speed of this car exactly at time t equal to 2 seconds, then that is what is called as instantaneous speed. Speed of a body at a particular instant of time. Suppose you are going in a car. Let us say you are going on a highway. Okay, you are going on a highway. On highway, you start your journey exactly at 6 a.m. Exactly at 6 a.m. and you are traveling for 2 hours, let us say, up to 8 a.m. Then, if I take a particular instant of time, which is 7 o'clock, 7 minutes, and 7 seconds. 7 hours, 7 minutes, and 7 seconds. That is particular instant of time. At this particular instant of time, with what speed is your car going? That is instantaneous speed. Okay. And this instantaneous speed is shown by the speedometer. If you look at the speedometer, if you go fast, speedometer shows the reading, like it might be going from, the reading might be 60, 70, 80, 90, 100, like that. If you slow down, the needle, the pointer comes down, 90, 80, 70, 60, 50. If the car is at rest, it will be at 0. If you again start moving, it slowly increases 5, 10, 15, 20, like that. So the speedometer, pointer of the speedometer always shows you the instantaneous speed. It is the speed at which you are going at that particular instant of time. That's what we mean by instantaneous speed. Instantaneous speed. And instantaneous speed is measured by speedometer. Speedometer. Okay. Fine. This is instantaneous speed. If you take average speed, see, again coming to this example, you start your journey at 6 a.m. and your journey ends at 8 a.m. That means you are traveling for 2 hours. You are traveling for 2 hours. And say you cover a distance of some 100 kilometer. We cover a distance of 100 kilometer and you take 2 hours to do that. Then if I ask you what is your speed, you will say it is distance by time. Distance is 100 kilometer. Time taken is 2 hours. So it is 50 kilometer per hour. 50 kilometer per hour. This is your average speed. The speed which we calculate using the formula distance by time is average speed. Why is it average speed? Practically thinking, you start your car at 6 a.m. exactly from 0 speed. Then you slowly increase your speed 10, 20, 30, 40, 50. Then let us say you reach a speed of 80 kilometer per hour. With that 80 kilometer per hour, you move for some time. Then immediately you come across a speed breaker. What do? You should reduce your speed. Again, it comes down to some 5 or 10 kilometer per hour. Again, you see a free road, then you again increase your speed 30, 40, 50, 60 up to 80. Then you come across a toll gate. There you have to stop. Your speed becomes 0. Again, after crossing the toll gate, there is traffic. You cannot go at 80 kilometer per hour. You go for some time for 50 kilometer per hour, sometime at 20 kilometer per hour, sometime at 100 kilometer per hour. Like this, you cover your entire journey of 100 kilometer at different speeds, at different instants of times. At some time your speed is 20, at some time your speed is 120, sometime your speed is 0, sometime your speed is 50, at some time your speed is 90. With these different speeds, you are covering a distance of 100 kilometer in 2 hour time. Then, if you write this distance by time, the speed that you get is your average value. It is just like your average mark. Suppose in English you score 85, in Telugu you score 90, in maths you score 95, in social you score 70, in science you score 75. If you add up all these marks and divide it by the number of subjects, the mark that you get is your average mark, right? If I say that the average mark of a student is 75, then it is not like in every subject he or she has scored 75 marks. In some subjects it might be 85, in some subjects it might be 50, in some subjects it might be 90, in subjects it might be 76. The average of all these values is this 75 mark. Similarly, the average of all speeds with which a body moves during a particular interval of time is average speed.
Sum of marks of every subject by number of subjects is average, sir. Okay.
Yes. So average speed is the average value of all speeds with which a body moves in a given interval of time. In a given time interval, average value. How do we measure this average speed, or how do we calculate this average speed? Average speed is calculated, or it can be calculated using the formula. Average speed is equal to total distance covered by the body by total time taken. Important formula to be remembered. Total distance covered by total time taken is average speed. Now, let us see how we calculate this average speed in different situations. How to calculate average speed in different situations. This is important. Okay, I'll take one example, one simple example. So let us say a body a car covers 100 meter in 20 seconds. It's okay, average speed. Let us say its average
5 meters per
speed.
second, sir.
Average speed, total distance by total time.
5 meter per second.
Total distance covered is 100 meter. Total time taken is 20 seconds, which is 5 meter per second. That's all. Okay. Mm. A car moves at 15 meter per second per 2 minutes. Distance covered is
Sir, 30.
More, sir.
Sir, 180. Is it 180 meters?
speed is distance by time.
Sir, and
Dis-
distance is speed into time.
Speed is 15.
15 into 120 seconds.
Time should always be in second, not in minutes or hours. So this is, how much is this? 15 into 30. 30 into 60.
Sir, 1,800 meters. Sir.
1500 meter is the distance covered.
1.8 kilometers. Sir.
Oh. 1800 meter is the distance covered. Basic things, just to refresh your formulas, all these things. There are different situations which we get while calculating average speed. We should discuss them in detail, but for now, that's it. We will discuss those applications in our next class. So I want you to understand clearly, revise once again, how to find distance displacement in different situations, and how to find speed, or not how to find, we'll do that in our coming classes. What is the difference between speed and velocity? That is what you should understand clear, so that you can easily follow the coming topics.
Okay, sir. Thank you, sir. Bye, sir.
Right, see you and good night.
Sir, bye, sir.
Thank you.
Bye, sir. Thank you, sir. Good night, sir. Sir, do we have an English class today?